Right, so question 12, part 1. For these identities, most often what we're using is using that one, the common one, sine squared theta plus cos squared theta equates to 1. And so I'm going to probably use that here. But one thing I really like the idea of doing, I see all these letters, and because it's a thick pen, I'm going to say, what about let's have u equaling sine squared theta. And then it just tidy things up. And in this case here, then I can also rearrange what cos squared theta equals in terms of sine, which is 1 minus sine squared theta. So in my example here, it'd be 1 minus u. So I'm just going to see if this works, because I think it looks quite interesting. So I'm going to replace everything I've got now. So I've got u minus 3 brackets 1 minus u plus 1 all over u minus bracket 1 minus u. And let's just see what happens here. Make sure I multiply out the brackets correctly. So I get u minus 3 plus 3u plus 1 all over 2u minus 1. Now let's tidy that up. I've got 4u minus 2 all over 2u minus 1. And that means I can take a factor of 2 out of the top here. Those cancel out and I equal it to 2. Boom. Now, the question is identify the values for theta, which can't happen. If this is 0, it's asymptotic. So it can't happen where sine squared theta equals cos squared theta. And you need to know where that happens. Right, so divide both sides by cos squared theta. Okay. So now you get cos squared theta over cos squared theta is 1. And the reason I did that is because I now know that sine squared theta over cos squared theta is tan squared theta. So now I can say tan squared theta equals 1. So you get tan squared theta equals 1. So let's just give myself some space here. So that means that tan theta equals the square root of 1 is plus or minus 1. And you should know that that equates to, if I did it like that, it's 45 degrees, 135 degrees, it's these angles here. So effectively it's 45 degrees. And then what you're going to do is it's plus 90, plus 90, plus 90. So it's 45 degrees plus or minus 90 degrees n. And I'm going to put, yeah, you can leave it like that. The way they like it, because it could actually be where n is 0, that could work. The way they like writing it is 90 degrees n minus 45. But actually it could be any of those ones. So question 2. Again, I'm wondering when I look at these ones whether I should be just doing that whole trick of letting u equal a value, because that can work sometimes, but sometimes you forget you've got sine squared, etc, etc. But what I'm going to do here is slightly different therefore, and I'm going to basically, this is a fraction, so I'm going to add the fraction. And remember, you're going to have the same common denominators, which gives you this. That's kind of neat. So I'm going to cross multiply. So multiply those two together and I get what I want underneath. And then that goes times up to there, that times to there. I've already done these ones here. So that gets me sine squared theta plus cos squared theta. And we know that equals 1. So we're left with that there. And then you have to consider, again, this is a good indicator of when it doesn't work. So you've got to know it doesn't work when that equals 0 or that equals 0. And so it doesn't work when you've got 180 degrees, because a square root of that, so it's just simply that. So it doesn't work at 180 degrees, so 180 n, nor does it work for 180 n minus 90. Okay, so if you remember the graph, what it looked like, the sine curve there, so it's where it's value of 0, so it's at 0, 180, 360, boom, there. And the cos curve, can I get this right, Simon? Okay, so the cos curve, it doesn't work at this point here is 90 and at 270. And so the way they describe that is they say it's 180 n minus 90, and that would describe those ones. Of course, there are other ways to do it. You could describe that if you wanted to be 180 plus or minus 90 n as well, and that's no, that wouldn't work so easily because it's going to be 180. Yeah, that would work, but n can't be 0 in this case, so that's a better way of writing it.